right, welcome to class, everybody. Today's lesson is section 6.2. Couple quick announcements though, to start off class. So I picked up your tests from the testing center. I have so much stuff to get done this weekend though, that they will probably get done by Monday, possibly Wednesday of next week. So I will give the test back next week. What other announcements? The unit 2 assignments closed yesterday, so hopefully you guys finished all of those. And so really the only assignments we've done so far in this unit that are still available for you to do are section 6.1 and 6.2, which we'll do today. So today's lesson is about multiplying and dividing rational expressions. So remember, rational expressions are basically like polynomial versions of fractions. So to start off our lesson about multiplying and dividing rational expressions, let's talk about how we multiply and divide fractions. So when we multiply and divide fractions, with multiplication, you multiply the top and the bottom of the fraction. So if you had 2/3 times 3/5, you would just do 2 times 3, which gives you 6, and 3 times 5, which gives you 15. And then you could also reduce that because both of those are divisible by 3. So you could reduce that to be 2/5. And one way you can think about the reducing, which was what we talked about last class, is if you think about 6 as being 2 times 3 and 15 as being 3 times 5, the 3's cancel out. So that's usually the way we think about it when we're reducing rational expressions with polynomials, because you may not necessarily know what 2 polynomials are both divisible by. But if you get them into factored form and you cancel out the common factors, that's how we reduce polynomial fractions. So that's how we multiply fractions. You just multiply the top, multiply the bottom. When you divide fractions, the way that I learned it in elementary school was that you take the first fraction and multiply by the reciprocal of the second fraction. So you may have heard it as like keep it, change it, flip it. Like you keep the same fraction the same, you change the division to multiplication, and you flip the second fraction. So the answer would be 21/8. But when I was teaching middle school, I had a student teach me a different method, whereas like that is way easier than the reciprocal method. So this is the method that I now use, even though I learned it as an adult. And instead of doing this whole reciprocal thing, you just multiply in a zigzag. So you go 3 times 7 is 21, and 4 times 2 is 8. And you can see you get the same answer. So I think that method is a little bit easier because one of the common mistakes is that people are like, well, wait, which one do I flip? You know, like, do I flip the second fraction or do I flip the first one? But the zigzag method will always make sure that you get the correct order of which one is flipped. And you can see you get the same answer, and the multiplication is still the same. You're still doing 3 times 7, whether it's the reciprocal method or with the zigzag method. So we're going to be using these two methods to help us multiply and divide rational expressions, which are fractions with polynomials. So let's say, for example, that we had these two rational expressions. And these ones are pretty simple because the polynomials that are in the fractions are just one single term. So if we were multiplying these together, we would just multiply the tops together, which would give us 14x squared y cubed over 30x cubed y. Because you just multiply the bottom polynomials together, multiply the top ones together. And then this can be reduced because 14 and 30 are both even numbers. So those can be reduced to be, like if you divide both of them by 2, that would be 7 over 15. And then if I have x squared over x cubed, I can think about this as being x times x over 3 x's. And same thing with the y's. I would have 3 y's over a single, y like that. And so if I think about them in kind of this expanded form, and I don't usually write them out, I just think about it in my head about what it would be. But if you think about it in this way, you can cancel out the common factors. So like x divided by x cancels out to 1, x divided by x, y and y. And that leaves you with a y squared on top and an x on the bottom. Yeah. Mm-hmm. Yep. Yeah, so you can you could do like 2 divided by 6 is 1/3 and cancel those out before. That would totally work. I usually prefer to do it afterwards though, because if you're doing division, you have to like think about the reciprocal thing and the canceling out. So I usually will multiply them together and then reduce them. But it does work to do it that way. Yep.
Putting in another way of the division thing. My brother calls it copy. So you copy the first one dot flip.
Mm-hmm.
So that's just that way you know which one to put on in first and second.
Yep, that would totally work too. So it doesn't really matter which way you look at it. So if that's the way you like to do it, that totally works. The main idea is just that with division, you multiply the top of the first one by the bottom and the second one. Okay, so this is how you would multiply rational expressions that are really simple like this with monomials. So let's talk about how we would multiply polynomials like these ones. So the process is still the same in the sense that we're going to take this polynomial and multiply by this polynomial to get the top, because when you multiply fractions, you just multiply straight across. However, I mean, one way I guess you could do it is to distribute all of this and like make this really super long, huge polynomial, but that's going to make it harder to reduce it and simplify our answer. So we're actually going to just leave it in this form, but we're going to get each of the polynomials into factored form. So for the first polynomial, I can see that both of them have a 4 in it. So that would leave me with 4 times a squared minus 1. But this is actually not fully factored because what is this? Yep, that's a difference of squares. And how can we factor difference of squares? Perfect. Yep, so I can factor that into a plus 1, a minus 1. And so this is the fully factored version of this polynomial. Everybody good with that? Okay, so then we'll do the same thing for the second polynomial, and this one is a trinomial. So I'll use my trinomial trick, and I'll say -6 times a squared. What are 2 things that multiply to that but add to -a? Perfect. Yep, because if you multiplied those 2 together, you would get -6a squared. If you add them together, you do get -a. So I'll split that middle term into those 2 terms, and then split it into 2 groups. The first group has an a in common. I'm left with a minus 3. The second group has a 2 in common, which also leaves a minus 3. So I have a minus 3 times a plus 2. So this is the factored version of this polynomial. And so I'll multiply that on the top. And then on the bottom, this polynomial, what could that be factored to? Perfect, yep, because you'd factor out the 2 that they have in common. So you'd have 2 times a plus 4. Everybody good with that? And then for my last one, I'll do a different color here. Let's do purple. For this last polynomial, we have a squared minus 4a plus 3. That's a trinomial. So I'll multiply 3 times a squared. What are 2 things that multiply to this and add to this? Perfect. -3. And did you say -1? Okay, perfect. Yep, because the 2 negatives will make a positive when you multiply. And when you add them together, you will get the -4. So I'll have those 2, and then I'll have a squared plus 3, split those into 2 groups. The first one has an a in common, so I'm left with a minus 3. The second one has a -1 in common, and we'll also get a minus 3. So we get a minus 3 times a minus 1. So kind of like our last lesson, the hardest part of doing these problems is the stuff that you guys already know how to do. It's doing all the factoring. Because the actual new concept is just that you take this polynomial, multiply by this one, and this one times this one. And then you simplify the result. So when I look through this, I see that I have 2 a minus 1s. So a minus 1 divided by a minus 1 will cancel out to 1. I also have 2 a minus 3s. If I do a minus 3 divided by itself, that also equals 1. And I can also simplify this because what's 4 divided by 2? Just 2. So I can cancel those out to be 2 and 1. So my simplified answer is going to be 2 times a plus 1 times a plus 2 all over a plus 4. And if you wanted to, you could FOIL this out and figure out what that is as a polynomial. But your homework system will still accept the answer like that. So I wouldn't recommend doing extra work. But this would be the simplified answer to this problem. Any questions on that so far? Okay. Why don't you guys go ahead and try this one on your own, and then we'll go through it together. All right, so when I factored them out, this is what I got. I did do it in my head, so is that what you guys got as well? This one is the one I'm mainly wondering about. I think that's correct. Awesome, cool. So now that I have everything in factored form, and notice that I took this polynomial times this one because we're multiplying the fractions, and so you just multiply straight across. And so once I have everything in factored form, then I can cancel out the common factors. So x minus 3 divided by x minus 3 will cancel out. X plus 2 divided by x plus 2 will cancel out. And it looks like that's everything. So I'll end up with 5 times x minus 5 over x minus 2. And this one wouldn't be terribly hard to distribute. So you could also just write this as 5x minus 25 over x minus 2. Either one of those would be correct. I usually tend to leave it in factored form, especially if your answer is more complicated. But either one of those would be correct. So any questions on that? Okay. On a scale of 1 to 5, how do you guys feel about multiplying rational expressions? Okay, awesome. So let's go on and do a division one. So when let's do a more complicated division one. Let's do this one. So if I'm dividing these expressions, remember when you divide fractions, you're either going to think about doing the reciprocal of the second fraction and multiplying them together, or you can use the method I showed you earlier where you do the zigzag method. So to find the answer to this, I'm going to take this polynomial and I'll get it into factored form. So 2x squared times negative 15 gives me negative 30x squared. The things that multiply to negative 30 and add to 7, maybe 10 and 3 maybe, where the 3 is negative. Yeah, that should work because negative 3 times positive 10 will give you the negative 30. And when you add them together, that gives you 7x. So we get 2x squared plus 10x minus 3x minus 15, split it into two groups. 2x is in common in the first group, so you get x plus 5. The second group has a -3 in common, which gives you x plus 5. Factor out the common x plus 5, and you get 2x minus 3. So again, this is just like review of the stuff we did last unit, factoring the polynomial so that instead of it being stuff added together, you have things that are multiplied together. So that's our first one. And then because we're dividing, we're going to multiply this by the bottom and then multiply it by the top. So I'm going to get this into factored form. And what does this polynomial, or how could I factor that polynomial? Yeah. Take an 8 out. Okay, so 42, I don't think actually is divisible by 8. Yeah, we could take a 7 out though. So 42 divided by 7 is 6. So we'd have 6x, and 56 divided by 7 is 8. Oh, which actually means we could also factor out a 2. So we should be able to factor out a 14. Because if you factor it and then the thing that's left still has something in common, that means you didn't actually get the greatest common factor. So since those are both divisible by 2, we can actually divide by 14. And 14 divided by 42 should be 3. I think. Is that right? And then 56 divided by 14 should be 4. So that would be our fully factored version of that one. And again, the reason why this is on top is because we're dividing. So when we zigzag, we multiply the black one by the red one to get that on top. And then find the bottom part of our answer. We'll take this polynomial, which has a 7 in common. So we'll do 7 times 2x minus 3. And we're going to multiply that by this polynomial. And when we factor that one, it's a trinomial, so we can use our trinomial trick. And 40x squared, the things that multiply to 40 and add to 13. Maybe, I think 8 and 5. Because 8 times 5 is 40, but 8 plus 5 is 13. So then I can split that into two groups, have an x in common, and that leaves x plus 8. In the second group, I have a 5 in common, which also from multiplying 40 times x squared for the trinomial trick. Yep. And then I'll pull out that common x plus 8 and x plus 5. And that's the factored form for that polynomial. And again, notice that this bottom part came from zigzag multiplying. And now that I have everything in factored form, I can cancel out the common terms. So 2x minus 3 divided by 2x minus 3 will cancel out. X plus 5 divided by x plus 5 will cancel out. And 14 divided by 7 can reduce to 2 over 1. And so it looks like my final answer will be 2 times 3x minus 4 all over x plus 8. And again, if you wanted to, you could distribute that too, but you don't have to. All right, so division is basically the same thing as multiplication, except that you're doing the zigzag pattern of multiplying versus multiplying straight across. So how do you guys feel about division? 1 to 5. Okay, awesome. So again, kind of the hardest part is just getting everything into factored form because it's just a lot of factoring, but it will also be good practice for everything we did last year. So the first question I want to go over on your homework is question 11. So if you guys want to open up your laptops and open up question 11, we can go through this together. Also, I forgot to mention this at the beginning of class. I sent out a survey like an hour or two ago. And the point of that is just like, I know you guys fill out the like feedback forms at the end of the semester, but I also think it's kind of dumb that it's the end of the semester because like the class is over, so I can't make the class better for you guys. So I do my own feedback forms around mid-semester just to see if there's anything that I could do to improve my teaching and make the class go better. And with you guys specifically, the main thing I want to know is like, do you guys feel like the time we spend learning the concepts is enough? Like the balance between like teaching time versus homework time, is that balance good for you guys? Or would you like more examples or less examples? That's kind of the main thing I'd like to know for your class, because I haven't taught a class this way before. So if you guys can fill that out, that would be great. Okay, are you guys ready for me to start on question 11? Okay, so the main thing I want to point out here, or the main thing I think that makes this question difficult, aside from the fact that you're going to have to factor a lot, is the fact that you have multiplication and division. So when we are multiplying these together, basically what we're going to do is we're going to multiply these straight across, and then we're going to zigzag and multiply that. So we'll do this polynomial times this one, and that will go on the top. And then on the bottom, we'll do this times this, zigzag up, and then come down. So whenever you divide, you do the zigzag pattern. But then the other part of it is also that you just have to factor a lot of polynomials. So for this first polynomial, and your guys's might be different, but for this one, this is a difference of squares. And so that means that I can factor that to be x minus 4y times x plus 4y. So that will be my first one. Then my next polynomial is a trinomial. So the way that I would factor this trinomial is take x squared, multiply by negative 20y squared. So I get negative 20x squared, negative 20y, or sorry, negative 20x squared y squared. I'm looking for two things that multiply to that, but add to positive xy. So I think that would be 5 and negative 4, because those would add together to the positive 1 right here. And then the letters would be xy and xy, because those will multiply to be x squared, y squared, and they'll add together to positive xy. So then I get x squared plus that minus 20y squared. Split it into two groups. You have an x in common, and then you get x plus 5y. The second one has a negative 4y in common, and so you get x plus 5y there as well. And so that polynomial will factor to be x plus 5y times x minus 4y. It's been a little while since we've done factoring with two variables. So are you guys good with that process of like how to deal with it when you have x, like y squareds and x squareds? Okay, so I'm not going to go through all the details of how to factor all of these, just because your numbers will probably be different than mine. But I'm going to kind of go through the process, and I'll do the factoring really fast in my head. So for this one, I did this times this, and then because I'm dividing by this next fraction, I need to multiply it by the bottom of that fraction. So I've done enough factoring to know that this is going to factor out to be x plus, or not plus, minus 3y times x minus 3y. You guys, unless, I mean, maybe you guys might be able to do it in your head as well, but you'll probably have to go through a process similar to this to get your own answer. But that's going to factor to be that. So that will be the top of my fraction. And then for the bottom of my fraction, I'm going to take this polynomial, which I think that factors to x minus 4y times x minus 4y. Again, you could use the trinomial trick to get that, but that's what that will factor out to be. And then this polynomial right here will factor to be, I think it's x minus 3y times x minus 4y. Yeah. So that will be that polynomial. And then I will multiply that by this polynomial, which is a difference of squares. So that can factor to x minus 5y, x plus 5y. So this red one and purple and green one, I just did in my head. But for you guys, if you can't do it in your head, which by this point you might actually be able to because you've done lots of factoring, but it's basically just going through this process I did in black here. Once you get everything all factored, and we've already done the zigzag thing, because I took blue times black, and then I zigzagged down and multiplied by the red and got that as the top of my answer. And same thing here, I did purple times green, and then I zigzagged up to the brown to get the bottom part of my answer. Once you have everything in factored form, then you go through and cancel out the things that are in common. So 4 or x minus 4y cancels out, x plus 5y cancels out, x minus 3y cancels out, x minus 4y cancels out. And I think that's everything. And so the answer would end up being x plus 4y times x minus 3y all over x minus 4y, x minus 5y. And that would be your simplified answer. Yeah. Yeah, so really like the hardest part of this assignment is again, the factoring. I feel like the actual concept of it isn't terribly hard. You just multiply straight across, or if you're dividing, you zigzag. It's mostly just a lot of factoring. So that's question 11. I don't think there were any other ones that really stood out to me. So do you guys have any questions you'd like help with, or? Okay, I'll let you work on your own then. This assignment is kind of short, which I guess is a good thing because each question might take a little while with all the factoring, but there's like about 12 questions for this assignment. So kind of there is, so like, you know, like with the trinomial trick, how you like take this one times this one. And then you find out like what two things actually, let's do black one since we already did that example. So like on this black one, we did x squared times negative 20y squared. We got that and we thought of two things that added and multiplied and stuff like that. If you look at what our final simplifying or like our final answer was, you'll notice that we have a plus 5y and a minus 4y. And that will always happen if this number has a 1 with it. So if the coefficient is 1, you don't technically have to go through this whole process because whatever the two numbers are that you find, those are going to be the two numbers in our final factorization. So that's how I did those in my head, was just because these were like coefficients of 1. If this was like a 2x squared though, then there's not really any other way to do it. You kind of just have to do the factoring later. I think that's the shortest shortcut, and it's not that short.